Every movement in this room is slow on purpose, and there is almost no room for error. This is handmade firecracker work, and one careless spark could change everything. Even the amount of powder per tray is limited, just in case something goes wrong.
To make something that explodes, they first have to control every part of the room.
These strips will become the thin shells that hold everything together.
A thin binder helps the shell keep its shape without adding extra bulk. Shells that feel too thin or too soft are pulled out immediately.
A solid plug at the bottom helps direct the effect upward instead of sideways.
Even before any powder go in, everything is counted and tracked.
Tapping helps the charge settle evenly, so each firecracker behaves more predictably.
This is still a small-scale shop, but even here, hundreds of pieces move forward every hour.
Every one of these tiny cylinders holds a controlled explosion, waiting for a fuse.
Random checks catch bad packing before fuses ever touch these shells.
A layer of inert material helps control how the firecracker bursts and protects the fuse seat. Fuse length determines how quickly the fire moves. Even a small difference can change the timing. Even a slightly misplaced hole can affect how the flame enters the charge. Each fuse is seated deep enough to catch reliably, but not so far that it chokes the burst. Loose fuses can fall out later,
and a silent firecracker is both wasteful and dangerous. Small bundles like this are easier to handle and position before they re-chain together.
Everything still looks rough and simple, but how these are handled now decides how safely they ignite later.
Each joint has to pass flame smoothly. A bad connection can stop a whole chain.
These assemblies have to move from table to test ground without shaking themselves apart. Longer runs give more impact, but they also multiply the risks along the way.
That tiny mark is where everything eventually begins, where they'll bring flame to life.
Any missed weakness here could fail later when sparks start running.
This is where everything converges, and if this joint fails, an entire section stays silent.
With the chains built and checked, the next step is seeing if they behave exactly as planned.
Every test shot is logged, so any problem later can be traced back to a specific batch. Even the short walk to the test yard is treated as a step that needs respect. The extension fuse gives the worker enough distance to light it without standing over the explosion.
This is the moment where their work either proves itself or reveals a problem.
Even after a good-looking test, they read the leftovers to see how cleanly the charge burned.
If the tests keep matching expectations, the rest of the batch can move toward packaging.
By this stage, the dangerous part is over. Now they focus on making it something people can actually carry home. All of this stays apart from the workrooms. One more layer of distance between people and what these boxes can do.
This is the same line you just watched being built, now doing exactly what it was designed to do.
For them, this is just another day at work, one where every careful movement keeps all that fire exactly where it belongs.